All right, everybody. Sorry, this is for a technical difficulty, but I am Ricardo Polanco from the Game Art program of Full Sail. This is my eighth month for Fundamentals of Physics with George Stewart, and today I'm here to talk about inertia. Now, right here in my hands, these are two eggs. I'll come back to these later, but right now we're just gonna stick to why I chose to do a project on inertia. You see, I had a cousin who was really interested into science, so I started thinking what nice little project that he can do involving inertia since he also kind of had a small little project that he needed to show up for class. So I kept thinking and thinking and thinking, and then I realized, I think I actually have a project he can work with. And it just involves those two eggs that I have way over there, but we will get into that. So today, my entire podcast will be about the very bare, just a bare basics project showing just how inertia works, even in small objects. Now you see here, I have two eggs, one hard-boiled egg, and one with the seal of approval saying it's a raw egg. Now, if you take the hard-boiled egg and shake it, there's no sound there because this egg is solid. Now, if you shake this one, if you shake a raw egg, you should hear the squish sound of the yolk. Now, the reason why I'm working with these two is because this is where we're going to apply inertia. Now, first off, we need to know what inertia is. And the simplest of terms I can put, inertia is a measurement of how hard would it be to change the momentum of an object. Now, this usually is all dependent on mass, but then there's also so many other key factors. For the first part, this is going based on Newton's first law of motion, which is an object that wishes to remain at rest will stay at rest unless an outside force is applied or something strong enough to actually change the momentum of an object. So now I'm lowering this so we can see our little eggs here. Now, when I spin the hard-boiled egg, look at that. That goes nice and smooth, and it actually comes up a little bit, and then it's there. But notice that. Really fast, and and with just one touch of my finger, or that, it just stops. Now, when we take the raw egg, you'll notice right off the bat, it's slightly slower, but this one actually has a unique property. Now, we have to remember that if an object wishes to remain at rest, it will, unless another object with an inertia greater than the object beforehand can stop it. Now, this is the interesting thing. We mentioned there is a liquid inside here, and there's already this hard shell. Now, watch what happens when I end up spinning this and stop it with this finger for about half a second. Now, if you just notice that, even though it's very faint, it still continued to move after it just stopped for half a second. Now, there's something that's going on inside here. The inertia for this, when I spin it, it wants to keep spinning. Then I put the finger. Then I let it go. And yet, on the inside, the liquid was still spinning, thus causing the egg to still move. So this proves that even though my finger actually had a momentum great enough to stop the inertia of the shell, the liquid in the inside still wanted to keep spinning. So because of that, the minute I let my finger go, this is why it started moving slightly. But in the end, when I do that again, it'll spin, but then it will eventually stop. Because when I've slowed down the shell then starts to slow down the liquid. So it pretty much acts as a chain reaction for it. That is actually probably one of the more bare basic ways of just showing exactly how inertia can work in even the smallest of objects. So with that, all I say is thank you for your time, and I hope this was informative to anybody. And have a good night.